This is a follow-up to the previous problem where we had an array of marks. So this was just random marks given from a class 45, 60, 77, 33 up to 60. So for this marks, you were supposed to find three integers within this array, and these three integers should sum up to 126. So for example, in this array, we can say we have 26 plus 40 plus 60, and they all sum up to 126. So the previous solution was had time complexity of about O over n cubed. So here we're trying to bring it down to at least O over n squared. So what we'll do is we'll create a first for loop. So the first for loop will traverse through our array and find our first integer. So after we find the first integer, then we'll simplify the problem to just finding the sum of two integers within an array. So I'll write the code, then you'll understand as we go on. So we define our function. I'll just name it as the same name we use, 3 mark sum. And our input will be marks and our target x. So the first thing we'll do is we'll initialize our len as n, length of our array marks. So remember I said that we'll have our first for loop for I in range. So for the first for loop, we're just trying to find our first integer, then we'll take it out. So after we're done with the first one, it's still similar to the last code we did, n minus 1. So after we're done with the first one, now we can put it aside and say, okay, let's try to find 2. So now we're focusing on finding the sum of two integers within an array, right? For I in range 0 to n minus 1. So what we'll do is let's just create a set. We'll call it 2 sum, because now we're focusing on the sum of two numbers. 2 sum. We'll create a set where we'll store each number we find that will be summed with I with an integer at index I, right? So to do this, if we know that the sum is equals to whatever number at I and two extra numbers, then we can say that the sum of two numbers, 2 sum, will be equals to x minus whatever number we have at index I, marks I, right? So now from here we have the sum of two integers. So we can say 2 sum is equals to the target sum we're given minus whatever integer we get at index I, right? So now that we have the sum of the two integers, now we can say, okay, for the second for loop, let's find another number. Now we have our first for loop. We go to the second one. We can say for j in. So now we're just trying to find another number within the three numbers set or three number array of integers within our main array. So we can say for j in range I plus 1 up to n. So we go to the end of our array. So we know that we have mark I, we have an integer at I, we have the sum, and now we have our new number j. So we can say that if, say, 2 sum minus, so now that we have an integer at j, we can say minus the mark or the integer at index j. If we deduct this number from this, we can get the other one, because now it's just two numbers. So what we're doing here is we have a sum of two numbers. To find an x number, if you have 1, then that number will be whatever we're trying to find. We have no idea what it is, right? So whatever we're trying to find will be equals to the sum of the two numbers, 2 sum minus the new number, which is marks j, right? So now we have the sum of two numbers, we have our third number, right? So we can say if this 2sum minus j is present in the set we created of these two numbers, is in two numbers, let me say two numbers set is in two numbers, then we know that we have our three numbers, right? Two num, okay, same spelling. So now if this is true, we can print out the three numbers are, so we have the first one as I already, we found mux I at index I, and the second one is j, mux j, which we just found out from the second for loop, and the third one will be mux j 2sum minus mux j, right? So now here we just giving an output of our three integers from index I from the first for loop and index j from the second for loop, and since we have the second one, we just deduct that from our sum of our two integers which we got here, and that gives us our third integer, all from the main array of mux, right? So if we have this, now we can return true, right? And remember, we have to append, we have to add the integer j of the two numbers in our set. So what we can say is 2 num or 2 mux added to the set, right? Add mux j. So the integer j we added to our two number set. But if all this is false, then we'll just return, get out of the for loop and return false. Return false. We just go through it one more time. We have the function 3 mux sum, mux and target x, and we initialize the length as n. Then we can say for I in range 0 to n minus 1, which is our first integer at index I. Then after we put that aside, we can say create a set where we'll store those two numbers when you find them. So we say two numbers is equals to target x minus mux I, which we already have. Now that we have our sum, we can say for j in range I plus 1, since we have I, we don't want to repeat I, so here we say I plus 1 to the last index, which is n, or to the length of the array, n minus 1. So we say if the sum of the two numbers minus mux, it should be mux j minus mux j is inside 2sum set, then we can print the three numbers as mux j, mux I, and 2sum minus mux j. Then we return true. Then we add mux j to our set, 2num.add mux j, and return false. Okay, perfect. So to run this, we'll just copy and paste. Our array and the target x. We'll keep target as 26. Since we know this one is true, we'll just see if we'll get the same output we got for the previous problem. Then we can play around with it after. We have our target, we have our array. Let's see if we'll get the solution. Yeah, perfect. So the three numbers are 26, 60, and 40. So this is from the print statement we did here within our second for loop. So it's true, we do have 26, 60, and 40, and all this sum up to 100 and 126, right? So let me just delete 60 from the array and see what I'll get. It's false. Perfect. So it works. If we don't have the three numbers, we get false, and if we have them, we get true. So this the time complexity of this problem is O of n squared. So it's